Welcome to clickmyproject.com. Now we discuss about the product reduced reference quality assessment based on the entropy of DWT coefficients of locally weighted gradient magnitudes. Now we discuss the abstract for the process. Perpetual image quality assessment, that is the IQA, attempts to the use of computational models of the estimate the image quality in accordance with the subjective evaluations. An RRIQA method can be make use of partial information of features extracted from the reference image for estimating the quality of disordered images. Finding the balance between the number of RR features and the accuracy of the estimated image quality is essential and important in IQA. In this process, we propose a training fee and the low-cost RRIQA method that requires a very small number of RR features. That is, the 6 RR features is extracted from the process. The proposed RRIQA algorithm is based on the discrete wavelet transform, that is known as the DWT of local weighted gradient magnitudes. We apply human visual systems contrast sensitivity and neighborhood gradient information to weight. We calculate the gradient magnitudes in the locality adaptive manner. The RR features are computed by measuring the entropy of the each DWT subbands. The DWT subbands have contains 4 subbands, that is the low, high, high-low and high-high. For each scaling and pooling, the subband entropies along with the orientation resulting in LRR, that is the low frequency RR features, on average entropy per scale for an local low level DWT. Extensive experiments performed on 7 large-scale benchmark datasets and also compared with the other existing process and the state-of-art that RRIQA method as an will fulfill for the reference and the both the textual and the neural process. Now we discuss the flow diagram for the process. This is the overall workflow for the process. At first, the input image is taken from the dataset. The dataset is the folder which consists of the several input images. After getting image from the dataset, we have to pre-process the image by using the CSF filter. This is the one of the pre-processing steps followed in the process, and then after the pre-processing, the pre-processed images get into the feature extraction module. In the feature extraction, we have to take the 2 extents of features. The first one is the gradient magnitude. From the gradient magnitude, the gradient value is obtained by the each pixel wise in the image. That magnitude values are gathered as an features. Then the DWT is applied for the image. After applying the DWT, the image is converted into 4 different types. The first one is the low frequency, that is the combination of low and low frequency, that is known as the LL. Then the second image is the combination of low and high frequency, that is known as the low high frequency. Then the third one is the high and the low combination image, that is the low high low combination image. Then the fourth one is the combination of 2 high level frequency image, that is known as the high high frequency image. By using the coefficient of these 4 images, the feature is extracted, and combining the gradient magnitude and the DWT coefficient, the feature value is evaluated, and then the image quality enhancement is obtained to enhance the image quality, and then the estimation is carried for the enhancement process. Now we discuss the initial running procedure for the process. At first open the MATLAB 2013 and change the directory as it is in the code. Now you can see the mainfile.m file. Select the mainfile.m and right click in that file. If you want to execute the code, click the option run. After clicking the run option, you can see the dataset folder. Open the folder, you can see the dataset image. Select the dataset image and click the button open. Now the selected image is undergone for the process. This is the overall output for the process. At first the figure 1 shows the input image that we have selected, and the second one image is the output image which is in the enhanced form. Now the third and the fourth image consist of the gradient map image. The gradient map image will extract the features from the image. This is the overall feature pixels that is selected from the image. After the completion of the process, the enhanced image is shown in the figure 2. Now this is the overall enhanced image corresponding to the features. Now the features quality will be denoted in the command window as an 5.2. Thanks for watching this video.